interval using our formula. Now we're just going to do a little something different with that confidence interval. So here's what we got. All right, I've separated you guys. You guys over here have scented paper, hence your paper with your scratch and sniff sticker on it, and you guys here have just a sheet of paper, unscented. And here's what we're doing in number 5. I'm going to see if the scented versus unscented produces better memory on the test. Okay, produces better memory on the test. So everyone that's got the scented, they take the test, they do their thing with the scented paper, they take the test, and guess what? They average the 23. Okay, they average the 23. You guys with the unscented, you average an 18. So can I say right now at this time that scented paper leads to an increase in your memory? I'm not confident in that. What if these guys over here are just better test takers than these guys over here? What if these guys here studied a little bit more than these guys here? Or what if it was just by random chance that I just put these people together and they did better? All right. So what we're going to find out right now in the next couple minutes is, was it really because of the scented paper or just by some other factors that I just discussed? All right. Everyone good? So the first thing we're going to do, yesterday we had what was called an observed proportion. Today what we're going to have is a difference in the means. All right. Difference in the means. And that's what we're going to find first here. All right. Is the difference of the two groups. So the difference of the means. And I have not done a good job as far as what symbols mean what, because your calculator tells you, the numWorks calculator tells you what the symbols represent. But this right here with X with the bar above it, that's your average, that's your mean. Okay, that's your mean right there. So again, the scented people took it, got a 23. Unscented took the same test and got an 18. So the difference in their means is 23 minus 18, 5-point difference. Okay, 5-point difference. And again, I want to figure out, was it because of this paper or was it because of some other random factor that went into it? All right, so to figure this out, we're going to switch up now. Okay, we're going to switch up. So be prepared to move, please. Be prepared to move around a little bit here. Okay, not everybody. All right, so here we go. 1, 2, 3. Switch with 1, 2, 3. Go ahead over, switch around. Just those guys. Bring everything with you, including your paper. Including your, I want you to take your paper with you, please. Yes. That's, sure. This is part of my showing you guys the deal here. I want you to take the paper with you. That's part of the experiment. So see what I did here? I just shuffled the groups up, didn't I? Now not everybody has scented and not everybody has unscented. I shuffled them up. I made them random. We're going to take the same test again. I'm going to figure out what the average is for this group now and the average from this group. Subtract them. I'm going to get a number similar to 5 and I'm going to plot it somewhere here on my dot plot. Right? So that's what I did. Right? I random group now. Random, just not scented versus unscented. Everyone see that? I do the mean. I subtract them. I get a number, and I plot it wherever it lands on my dot plot here. All right? I'm not going to have you guys move again, but you know what? We're doing that 1,000 times. Switching people up. Keep switching. I'm going to do the mean again. Subtract them. Everyone see what I'm doing 1,000 times. That's what, there's 1,000 dots on here. All right? And I want to know, where's our 5 fall? All right. Is that part of the randomness in here? Or is it an extreme value? Because if it's an extreme value, it was because they had the scented paper that they did better. All right. Versus all the values that was all random. So how do I test if our difference is significant or not? We find that confidence interval we've talked about the last 2 days. All right. So help me. I've given you some information on the top corner like I usually do. Help me find the confidence interval. All right, help me find the confidence interval. And that's what we're going to do here. Determine the middle 95% and the difference in the means. So you guys help me. How do I find the CI here? Mean plus or minus 2 times or the margin of error, right? I'll put MOE. And remember how we find the MOE? Plus or minus 2 times the standard deviation. Okay, so let's find it. Let's find our confidence interval. Remember, all these dots on the dot plot just represent a random grouping. All right, some have the percentage, some don't. All these plot dots mean they have random sampling. And please start paying attention to the directions. Make sure I hand back your quizzes. Speaking of following rounding directions, pass back your quizzes at the end of today's class. So 0.030. Make sure, watch the rounding directions because I want this interval, 95% confidence interval, to the nearest hundredth. I could follow my own directions. How do we match up there? Everyone getting the same thing? Making sure that's the first hurdle we got to cover is making sure we find the confidence interval. We're good there. Okay, so what we're saying, 95%. Remember, our random shuffling here. There's 1,000 times we did, 1,000 different groups we calculated the averages, the difference in the averages. 95% of them, the difference in the averages were about -3 one way to +3 the other way. One group did 3 points lower, the other group did 3 points higher on average. Where's our 5 fall? Where's our 5 fall? In there or outside there? Outside. That's inside or outside? Outside. So all of these happened by random chance, and our 5-point difference fell on the outside. That is significant. That's telling you guys that you guys didn't score 5 points higher just by random chance, all right? Because you would have fell within here. It's telling you that because your 5 is on the outside of that 95%, it's because you scored higher probably because of the Senate paper. It is significant if it's on the outside of my interval. Let me say that again. It is significant if it's on the outside of my interval. So when it asks for, is the difference in the mean statistically significant? Yes, it is. Yes, it is significant because 5 falls where? Outside our confidence interval. And that's how all these are going to get done today. Is our number inside? If it is, it's not significant because you know what? It just happened by random chance. It's like the rest of them. All right, but if it falls outside, oh, that's special. That is a special one. It is significant outside the confidence interval. So it is significant, that 5, and we can lead to conclusion that we probably got better grades because of the sniff test. Questions there? Find the interval. If it's inside, it's not significant. If it's outside, it is significant because it's not with the rest of them by random chance. Is that kind of making a little bit of sense before we go? Because there's going to be some drawbacks to this. If you want to pass around the sniffs, I'm going on to a new experiment, but I think it's cola, strawberry, apple, and sea breeze. If you want to pass them around and get a little sniff there. All right, get the brain power going. Okay, we all good? Questions? Now what I need to show you, what if they don't have these numbers? What if I can't build a 95% confidence interval, but I want to still see if this number is significant or not? Go to the next example. Problem number 6, please. So does studying with classical versus studying versus rap, does it make a difference or not? All right, that's what we're studying here. So the kids who studied with classical music in the background or taking the test with, I think, with classical, that's what their grades were. And the kids who studied with rap in the background, that's their grades. Okay, all good? All right, so John already did the difference in the means. It was 7. Okay, so he calculated the mean for classical, he calculated the mean for rap, and the difference was 7. Okay, the difference was 7. So that's our number. Like 5 was in the last one, 7's our number now. How did John obtain this value? And what does it mean as far as the problem goes? Well, how did he obtain this value? He subtracted the means of classical and rap. And here's where I'm going to need you guys to take over. What does that 7 actually mean here? Because the Regents loves to ask this question. What does that number mean as far as the problem goes? What was 7? What was 7? Talk to me here. What's the 7 mean? In your own words. You're not going to be wrong. In your own words, what's that 7 mean? Richie, go ahead. Take a stab at it.
The classical mean was 7 higher than the rap mean.
Well, yeah, on average, the kids who listen to classical scored 7 points higher. Okay, that's what it means. All right, so on average, classical scored 7 points higher than rap. All right, and here's the clincher. Is there significant difference in the quiz scores? Meaning, is that 7 significant or not? Now, usually, right? Usually I'd find some numbers up here and I do my confidence interval, see where 7 lands, inside or outside, right? Well, there's nothing there. So sorry, kids. So sorry. All right, but we need to figure out, first of all, does everyone see where 7 lands on this dot plot? Towards the middle or way on the outside? Way on the outside. So that should start giving you what? A little sense of this is going to be significant. It's way on the outside. It's not with all the other dots in the middle. So that should start saying, all right, I know what the answer is going to be, but how do I show this now? Great question. That interval we do is what percent? 95, right? That interval we do is 95%. How much is left? 5%. So if any score falls 5% on the outside, and I'll show you how to determine that, it's going to be significant. All right, we don't want it to be part of the 90%. It's significant if it's not part of the 95%. It's part of the 5%. Now, how do I determine that? First, how many scores are there here? You guys reread the problem here. How many times did I do this simulation? 250 times. All right, so what we're going to do is, all right, out of those 250, and what was our number we're testing again, if it was significant or not? 7. How many times was it 7 or above? So here's 5. That must be 6. All right, how many are at 7? 3. And then we got to do anything above it, which would be what? So there were 4 times out of the 250 we did it, that it was at our number or above. Got your calculator? What percent are we talking about here? Percent. I don't want a decimal. I want it as a percent, please. About what? Everyone getting about 1.6%. Is that part of the 5 or under we needed? Yes. So what can we say here? Is there significant difference? Yes. Because 7 falls outside, and you could still write it falls outside the 95% confidence interval. We just calculated it a different way because 7 falls outside the 95% confidence interval. So it does seem like listening to classical music does help you more on the test versus the rap. I get a number like 10%, 20%. No, that's going to fall within my 95% then, right? It's got to be outside. Go ahead, Harper.
I don't think I heard you when you said it, but why is it 4 and not 3 above the 250?
Say that again.
Why is it 4 and not 3 above?
Because you always want to go at your number or above. At your value or above, okay? At your value or above. Or if it was down here, it would be at your value or below, okay? You want to make sure how many are below or depending on what side you are. Like we know this is halfway. All right, so if my value was here, I'd count this and below. If it was over here, I'd count this and above. Good? Okay, everyone all right? I want to do another one of these where you cannot calculate the confidence interval on your own. All right, so we're going to keep going backwards now. Number 4. You guys just read through it for me. Read through it. Thank you for staying with me and keeping up here. And I take this very seriously this day because it's going to be on the Regents exam. They always ask these questions. And it's usually worth anywhere from 4 to 6 points. And it's something our calculator can't do. Okay, so you guys see group 1 is the tutoring, group 2 is the online tutoring. Okay, group 1's the human tutoring, I guess, and then group 2 is the online tutoring. And here's what they ended up with for test scores for the mean. The tutoring people got 80.16, the online group got 83.8. So again, we're going to ask at the end, is there significant difference between the grades, aka did group 2 score higher because they had the subscription versus the human tutoring? So first question, calculate the mean difference and they tell you what order to go in. Okay, they want to do group 1 minus group 2. All right, so let's do that, please. Not just the highest minus lowest. They'll tell you what order to go in. So the mean difference here. Group 2, which group 1, 80.16 minus 83.8. That's going to be a negative number. Negative 3.64. Okay, what's that mean to us? Because then it says, and explain its meaning in the context of the problem. Somebody in their own words. Gabby, go for it. Let's roll. On average,
group 1 had a less 3.6 less than group 2.
Yeah, points, right? We want to make sure we say points on the test. Or you can reverse what Gabby said and say on average group 2 scored 3.64 points higher than group 1. Okay? Good, Gabby. Good job. Yep. I always just want to make sure you guys write on average first because these are averages. So on average, I'll do what Gabby's just said. On average, group 2, or group 1, sorry. You started with group 1, right, Gabby?
Yeah, I think so.
Group 1 scored 3.64 points lower than group 2. All right, we're ready to test the significance or not. Okay, are these scores significant because, or is it just by random chance? All right, what's our number we're testing? Again, I can't make an interval. Sorry, no 95% confidence interval to build. Find out where that is. Find it on the graph right now. Find it on the graph. This is where estimation is okay. I am not going to take off because it's actually 12 and you put 11 down. All right, I'm not going to do that to you, especially on something like this. All right, so 3.64. Let's see, what are we going by here? Looks like we're going by halves, right? So -3 would be right here. 0.64, something like right here, I think. Those two bars right there. Or did I miss one? Looks like they're going by halves. There's -3 in the middle of -2 and -4. So there's -3.5. So it would be right in this region here. All right, so if you guys look at the frequency, can we just agree as a class about how many now? About how many are at -3.64 or below? If you just estimate here. Looks like one bar is at about what, 7, 6, 7? And the other one's at about what? What do you think? 2, 3? Again, I'm not going to be critical of that. All right, as long as you're in the ballpark. So what are we gonna say as a group? 8? Okay, I'm fine with that. 8. All right, 8 out of how many are there here? There you go. 8 out of 500. I put 9 down on my notes. Who cares? Right? I put 9 down. So that's about one. What do I have? What do you guys have? I have a different one. 1.6%. And what are we looking? If it's under 5%, right? The 95, and then you have the rest, which is 5%, which this is. So I know there's a lot of yeses today, but I just want to prove the point. Yes, there is significant difference. Because, what was our number? -3.64 falls outside the 95% interval, confidence interval. So it looks like the tutoring paid off. Questions? All right, I got really one more for you. I just wanted to make sure you get a yes question or a no that it falls inside. So let's go to Big Gabe. Do I have any gardeners in here? Anybody grow some fruit, vegetables? No?
No.
Okay. So basically, guys, we had 13 tomato plants that I put in black plastic mulch, and then 13 that were not putting any mulch. All right. And the tomatoes grew. We checked the weights, and what happened? On average, what do we have? The ones in the plastic mulch were 5 ounces bigger. Okay, 5 ounces bigger. So I'm already telling you what the number we're looking for is. It's 5. All right, it's 5. So I took the weights of the no mulch, weights of the mulch. There was a difference of 5. Was it because of the mulch or not? That's what, or just by random chance. There is definitely a difference, right? It's 5 ounces, so there definitely is a difference. I just want to know, is it by random chance, or is it because of the darn mulch? So I don't need to calculate anything here. I already know it's 5 ounces greater. I don't need to calculate that. So everyone locate where about 5 is right now. Everyone see where about 5 is on our dot plot. 2, 4, 6, 8. I don't know, 5. I'm going to go halfway right here. 5's right about here. I think we know what the answer is going to be, right? It's not on the extreme outsides like the last couple were. So I think we know what the answer is going to be, but We just got to mathematically show me why. All right, so let's make a decision. Count how many are at or above. All right, because I got to see if it falls within that 95 or outside. So I'll take different suggestions here. We'll agree on a class how many. I have a number written down, but so count those suckers up. And the only time I need to do this method is if I can't calculate the confidence interval because they don't give me the mean or standard deviation. What do we got? Different suggestions?
41.
41?
I got 34.
34?
Yeah,
No?
I got 39.
39?
Yeah.
41?
We're counting the one that is
Yeah.
not like the taller one. That's
Wherever you think. And honestly, it doesn't matter what you tell me. We're all going to get the same response. All right? We're all going to get the same. Nobody's going to tell me 2. Are we all right? You're not going to tell me 5. All right? It's going to be like I had 29 written down. All right? It's not going to matter. We're all going to get the same answer here. And so whether fine, let's just agree on something. I think average wise 38. I'll go 38. All right, so that satisfies the 41 and the 30 people. I'll go 38. All right, so it was 38 of these out of what? 100. They tell me 100 times. So that's going to be 38%. Whoa, baby. Does that fall inside or outside then? Inside. All right, so let's answer this question now. Which appropriate inference can be drawn? There was no effect. Well, there definitely was because one was 5 ounces greater. So it can't be. There definitely was. There was an effect that could be due to random assignment. All right. And that's the one we want because it wasn't due to the mulch, or if it was due to the actual mulch, this thing would be 5% or less. Okay. It would be 5% or less, and I'd be picking 3 or 4 here. All right. Everyone see there. It's significant. I can't stress this enough. It will be significant if it's on the outside of your interval. Are we comfortable finding the interval without given mean and standard deviation? We got to do it 38 out of 100, 7 out of 250, whatever our numbers were. If you can calculate it, you calculate it. Watch. This is where I'm going to leave it at today. Number 5, we could calculate it, right? Because it gave us these values. Calculate it then and see where your number falls in. If it doesn't give you the mean and standard deviation, then we got to count how many are at or above or at or below and put it over the total to see if it's 5 or below percent. Questions there? Okay, there's no assignment there, but what I'd like you guys to start doing, all right, start going to the review, please, because this will save us some time tomorrow. There's some I want to talk about as a group tomorrow, and I don't want you to do. All right, so why don't you start with number 12? Okay, this is what we just did today. Start with number 12. Talk it over with everybody else if you need to.